Welcome guys, James here, and today we're going to be going over the Chemistry 151-12 GLA. We're going to be talking about VSEPR theory, and we'll be doing problems A, B, and C in the extra practice section. So it reads, identify both the electron and molecular geometry around the central atom of each of the following molecules or polyatomic ions. So first we'll look at HCN, and we'll go ahead and draw out the Lewis dot structure for it. We know that hydrogen has 1 electron, carbon will give us another 4, and nitrogen has 5 in its outermost shells. So that's a total of 10 electrons that we'll have to use when drawing the structure. We did this in the Chemistry 151-11 GLA. So if you're not sure how to get to this point in the problem, I would recommend going back and looking over there. 2, 4, 6, 8, 10 electrons are being used here, so we don't have to worry about this anymore. Next, what we want to do to identify the molecular and electron geometry is you're going to look at the central atom, and you're going to count how many electron groups there are. Not electrons total, but electron groups. So on the left side, we have 1 group of electrons. On the right side, you have 1 more group of electrons. So we'll say that this has 2 electron groups. Both of them are bonding electron groups. So we'll say 2 bonding electron groups, and we'll get into why this is important later. But because there are 2 electron groups and they're both bonding electron groups, it's going to have a linear electron geometry and a linear molecular geometry as well. And that's part A. Next we'll look at part B. Hydrogen has 2 electrons, carbon is going to give us 4, and oxygen will give us 6. That's a total of 12 electrons. So I'll go ahead and draw out what this molecule looks like. Let me switch this to make this look a little better. Here we've only used 6 of the electrons, so we need another 6. If I make this a double bond and add 2 more to the oxygen, I'll avoid formal charges, and this is a very steady state, so this is the molecule we're looking at. We'll go ahead and look at the central atom. Carbon now has 1, 2, 3 bonding groups. All 3 groups are bonding electron groups. Therefore, the electron geometry and the molecular geometry are both going to be trigonal planar. So, trigonal planar electron geometry, and it's also going to have a trigonal planar molecular geometry. So that's how you do B. Go ahead and take a look at part C. N is going to be bonded to 3 H's. And it's going to have a lone pair up here. We did this one in the 151-11 GLA as well, so if you don't know how to do that, I just recommend taking a look back over there. In this compound, nitrogen has 1, 2, 3, 4 electron groups. 3 of them are bonding groups because only 3 of them are actually making bonds with other elements. Then you have 1 lone pair group. Now if you have 4 electron groups, what that's going to do is it's going to make your electron geometry tetrahedral. So we'll say tetrahedral electron geometry. And because we only have 3 bonding groups and 1 lone pair, that's going to make our molecular geometry trigonal pyramidal. So those are what this element is. If we had 4 bonding groups, so instead of a lone pair being up here, if we had an element that had 4 bonds, both the electron and the molecular geometry would be tetrahedral. But like I said, because we only have 3 groups and 1 lone pair, that's going to change the molecular geometry to trigonal pyramidal. So thanks, and I'll see you guys next time.